Test 6, Part 1, Passage 1. Listen to a conversation between a student and a Career Center employee.
Hello, welcome to the Career Center.
Hi, are you Sandra Evans, the career counselor? We briefly spoke on the phone yesterday.
Oh, Sandra is out for lunch. She should be back by 1 o'clock or so. Would you like to wait here until she gets back?
Actually, I have a class that starts at 1. Is there someone else I could talk to? I just had a few questions about applying for summer jobs.
Oh, I can help you with that. What type of information are you looking for?
I'd like to get an internship during the summer. Paid or unpaid is fine.
Unpaid internships are definitely more common, but you can still get some valuable experience that will help you down the road.
Yeah, that's really the most important thing for me, getting some experience.
What's your major, if you don't mind?
Not at all. I'm majoring in marketing and public relations. I was really hoping to find a position where I can use what I've learned to help organize events.
Sure. Have you checked the Career Center website for job advertisements?
I haven't yet. I thought it'd only include jobs available on campus, and I'm looking for something off campus, so I thought I might just have to contact companies directly.
Well, you can definitely do that, but our website compiles a lot of relevant data, so finding a job that suits you is easier. For example, it updates available positions daily and includes detailed job descriptions, so you could search specifically for marketing internships.
What about the interview? Can I set that up through the website too?
No, you'd set up the interview directly with the interviewer. Do you have any applications out there yet?
I sent applications to a few well-known marketing firms, but I haven't heard back from any of them. You know, I spent a lot of time preparing my cover letter, but I'm starting to wonder if it needs more work.
I see. Our website includes a list of tips for writing cover letters. For example, it's necessary that your letter show employers how your experience matches what they're looking for. It might be worth looking over before you send out any more applications.
Yeah, and another big issue for me is the layout of my resume. I'm applying in marketing, so the application I submit should really sell me to the employer.
Well, we do have advisors here who can help you improve your resume. There's a form on our website. Just upload your resume and you should receive an email reply within a day or two with some specific suggestions. It's a service I highly recommend. An attractive resume can make a huge difference. Of course, there's more to it than that.
What do you mean?
I mean, a resume isn't everything. We hold workshops that offer specific feedback on your job applications and also provide information on how to make a positive impression during an interview. Plus, I think they let you rehearse interview questions. You know, once you've had some practice at a workshop, real interviews will be a lot easier for you. I'm sure you know how daunting they can be.
It sounds like a pretty big time commitment. Do you think it's worth it?
Absolutely. I know they've really helped a lot of students with the application process. I've heard quite a few success stories from students who've attended a workshop here.
Okay, what's the schedule like? I'm a very active member of the literature club, and I'm a bit concerned the workshop sessions will overlap with my club activities.
That's not a problem. If there's a conflict, just notify the staff in advance so that they can adjust the schedule a bit.
That's good to know. Thanks so much for your help.
No problem. Drop by any time if you have any questions.
Now get ready to answer the questions. You may use your notes to help you answer. 1. Why does the student go to the Career Center? Two. According to the conversation, what can the student do at the website? Listen again to part of the conversation. Then answer the question. I thought it'd only include jobs available on campus, and I'm looking for something off campus, so I thought I might just have to contact companies directly.
Well, you can definitely do that. But our website compiles a lot of relevant data, so finding a job that suits you is easier.
3. Why does a woman say this?
Well, you can definitely do that.
Four. What does a student imply about his cover letter? Five. What does the employee say about the workshop?
Test 6, Part 1, Passage 2. Listen to part of a lecture from an Earth Science class.
Let's return to precipitation. By now, you should all have a clear understanding of the various mechanisms that cause water in the atmosphere to fall to the Earth as rain. We're going to now look at a related phenomenon, snowflake formation. We will also examine how this process results in atmospheric pollutants being carried to the planet's surface. Okay, the first to keep in mind is that a snowflake is not a frozen raindrop. That's a common misconception. In fact, snowflakes form when water vapor in the air is converted directly into ice. This occurs in one of two ways. The first happens when air temperatures are between 0 and minus 36 degrees Celsius, and it requires the presence of an airborne particle to act as a nucleus. For example, a small piece of dust or pollen. In this situation, supercooled water vapor in the air will condense on the particle's surface and freeze, forming a minuscule ice crystal. However, once temperatures drop below minus 36 degrees, there is no need for a particle to act as a trigger for snowflake formation. The water vapor in the air will simply transform into ice crystals. But regardless of which way they form, these initial specks of ice are called seed crystals because they serve as the basis for larger, more complex snowflakes to develop. Seed crystals always have 6 sides. They're hexagons. And it is this initial form that results in the basic shape of a snowflake. Take a look at this picture of a typical snowflake. See how it has 6 arms? As more and more ice accumulates, it projects outwards from the corners of the original seed crystal, forming the complex arms of the snowflake. Of course, as the snowflake increases in size and mass, it begins to fall towards the Earth. And this gradual descent affects its shape and size as well. Anyone want to take a guess as to why?
Wouldn't the air be warmer at lower altitudes? Maybe that has some sort of effect on the snowflake.
It isn't that the air gets progressively warmer. It's that temperatures and humidity levels fluctuate significantly as the snowflake moves through different air masses. Exposure to these changing atmospheric conditions determines the thickness of something called the quasi-liquid layer. You see, There is a thin film of water on the surface of ice crystals that is, well, it's neither frozen nor liquid. It's somewhere in between. And it's the molecules in this layer that bond with those in the surrounding air. As a result, a snowflake's growth pattern is determined by the thickness of its quasi-liquid layer. When the surrounding air is cold and dry, this layer is very thin. So the snowflake develops long needle-like structures as it expands. But the quasi-liquid layer thickens in warmer, wetter air, which leads to the formation of flat, plate-like structures. And the longer the snowflake spends in the air, the more complex its shape will be. It is subjected to a wider range of atmospheric conditions. Now, the other thing I want to discuss is how the process of snowflake formation can result in the transfer of atmospheric pollutants to the ground. This happens in a couple of ways. The first goes back to what I mentioned earlier about water vapor crystallizing around airborne particles. Sometimes these particles are pollutants such as lead. So the snowflake has a toxic substance at its core and transports it all the way down to the ground. Yes?
I thought you said that snowflakes don't always need, particles to form. So this means that snowflakes that develop in colder temperatures are, free of pollutants.
Well, that brings me back to the quasi-liquid layer. Even if a snowflake doesn't develop around a pollutant, it still has a pretty good chance of picking up other harmful substances as it falls, and actually transforming them into something worse. This process involves certain types of industrial contaminants in the atmosphere, such as nitrogen oxide and sulfur oxide. And coal power plants are largely to blame for the high amounts of these gases in the atmosphere, which is especially outrageous considering how unnecessary it is to burn coal when there are so many alternative energy sources. Anyway, when these gases come into contact with the quasi-liquid layer surrounding a snowflake, they react with the water molecules to create nitric and sulfuric acid. You've all heard of acid rain, right? It's the same basic idea, but in this case, it is acid snow. The fact that snowflakes carry acidic substances is obviously a concern, but the problem is magnified by the manner in which these pollutants enter an ecosystem. In many regions of the world, snow accumulates on the ground over the course of several months and then melts very quickly at the beginning of spring. So large amounts of pollutants are released in a very short period of time. This phenomenon is called an acid pulse, and it can have devastating consequences. For example, a recent study showed that over 50,000 young fish died in a lake in New York State due to contaminants from melting snow entering the water. Obviously, we need to find some way to prevent this from happening in the future.
Now get ready to answer the questions. You may use your notes to help you answer.
6. What is the lecture mainly about? Seven. According to the professor, how do seed crystals develop? Eight. In the lecture, the professor identifies several factors that affect the development of a snowflake. Indicate whether each of the following is a factor. 9. What is the attitude of the professor toward coal power plants? Ten. What leads to the creation of acid snow? Listen again to part of the lecture, then answer the question.
This phenomenon is called an acid pulse, and it can have devastating consequences. For example, a recent study showed that over 50,000 young fish died in a lake in New York State due to contaminants from melting snow entering the water. Obviously, we need to find some way to prevent this from happening in the future.
11. What does the professor imply when he says this?
Obviously, we need to find some way to prevent this from happening in the future.
Test 6, Part 1, Passage 3. Listen to part of a talk in a geology class.
Well, I guess we should get started. Before we get too far, though, let me ask you a question. What's the difference between magma and lava?
They're both associated with volcanoes, right?
That's true, but you haven't really answered my question. Anyone else?
I know lava is the molten rock that, spews out of a volcano. Is magma a gas?
No, magma isn't a gas. This information is in the chapter I assigned last week. Did anyone actually read it? I guess not. I think I may have to schedule a test on this material, so everyone better pay close attention to the lecture today. Magma and lava are both molten rock. In fact, there are no physical differences between the two substances. However, magma is the term used to describe the molten material that is found underground, usually in the magma chamber of an active volcano. Lava, on the other hand, is what this same material is called once it's ejected to the surface during a volcanic eruption. As I am sure you all know, a volcano is simply an opening in the surface of the planet that allows molten rock and gases to escape, what is known as an eruption. This process tends to follow a cyclic pattern. The gradual increase in molten rock and gas in the magma chamber leads to a rise in pressure until it reaches the point of eruption. Once an eruption has occurred, the magma chamber will again begin to fill. The lava that is ejected from the volcano usually solidifies fairly quickly. As successive layers of lava cover the surrounding area, they create a distinctive mountain-shaped formations that are associated with volcanoes. However, the intensity of the eruption and the composition of the lava determine the type of formation. There are, in fact, several different types of volcanoes. Today, we are going to discuss shield and stratovolcanoes, two of the most common types. Now let's look at some of the key characteristics of a shield volcano. I guess the most obvious indicator of the nature of this type of volcano is its name. If you'll look at this slide, you can see that a shield volcano actually does resemble a giant shield lying on the surface of the planet. These large, dome-shaped mountains are composed of basalt, and their distinctive shape is the result of their unique pattern of eruption. Shield volcanoes do not usually have explosive eruptions. Instead, the lava tends to flow slowly in all directions from the central vents. The basalt lava is very liquid, so it can travel quite far before it cools. As a result, the slopes of this type of volcano tend not to be very steep. They rarely exceed 6 or 7 degrees. While small shield volcanoes form very quickly following a period of almost continuous eruptions, the larger ones take much longer, in some cases over a period of millions of years. Regardless of size, shield volcanoes erupt very frequently, usually once every 2 or 3 years. The Hawaiian volcano Mauna Loa is a typical shield volcano. However, if you look at this picture, you can see that the angle of its slope is not very steep, even for a shield volcano. This is because there are a series of secondary vents that surround the summit. They release lava during an eruption in conjunction with the central vent, allowing the lava to travel much further than usual. Mauna Loa is the largest volcano on the planet. Its summit is around 17 kilometers above its base on the seabed. All of the Hawaiian Islands were created as a result of volcanic activities such as this. In fact, there are over 17 active and inactive shield volcanoes in the region. As with all areas that have shield volcanoes, Hawaii is situated over a hotspot, a section of the Earth's crust that is thin enough to allow magma to escape. This has made the Hawaiian Islands a popular research destination for volcanologists. Well, that and the fact that these gentle eruptions don't pose much of a threat to those observing them. This isn't true of stratovolcanoes, which make up the largest percentage of the Earth's volcanoes. Stratovolcanoes are characterized by eruptions of andesite and dacite lava. This is much cooler and viscous than the basalt lava of shield volcanoes. As a result, the magma of stratovolcanoes will usually clog up the central vent. It kind of acts like a plug in a bottle of champagne. This means that a stratovolcano will go much longer between eruptions, with a corresponding increase in pressure. Most stratovolcanoes erupt about once every 35 to 45 years. Of course, it varies from volcano to volcano. Anyway, when this type of volcano does erupt, it is very explosive. Can anyone think of an example of this type of eruption?
Yeah, Mount St. Helens, right?
Exactly. And the devastation caused by this eruption is characteristic of a stratovolcano. Now, as with shield volcanoes, the manner of eruption is responsible for the stratovolcano's distinctive shape. As the lava and volcanic ash burst from the central vent, it will usually fall back on the summit of the volcano. As a result, stratovolcanoes are very steep and usually have a conical shape. Actually, this is the type of volcano most people are familiar with. Stratovolcanoes are commonly found along subduction zones. These are areas where two tectonic plates meet. For example, the Mediterranean is a region that includes many stratovolcanoes, because the African and Eurasian plates connect at this point.
Now get ready to answer the questions. You may use your notes to help you answer. 12. What is the main topic of the lecture? Listen again to a part of the lecture, then answer the question.
Well, I guess we should get started. Before we get too far, though, let me ask you a question. What's the difference between magma and lava?
They're both associated with volcanoes, right?
That's true, but you haven't really answered my question. Anyone else?
13. Why does the professor say this?
That's true, but you haven't really answered my question.
"14. According to the professor, what distinguishes lava from magma? "15. The professor identifies several characteristics of shield and stratovolcanoes. Indicate whether each is a characteristic of a shield or stratovolcano. "16. What can be inferred about stratovolcanoes? "17. Why does the professor mention the Mediterranean region?